Hollywood movies have primed us to expect massive armadas and sudden planetary invasions, but the physics of the cosmos suggests that an actual encounter with extraterrestrial life would look nothing like the films. Looking purely at the numbers, the idea of an empty universe is difficult to justify. The observable universe contains roughly 2 trillion galaxies, each swirling with billions of stars. This map shows our own Milky Way galaxy. If we narrow our focus to rocky worlds sitting in the Goldilocks zone, where liquid water can pool on the surface, astronomers estimate there are at least 300 million potentially habitable exoplanets in our galaxy alone. In 1961, astronomer Frank Drake formulated an equation to estimate the number of active communicative civilizations among those stars. Even with conservative variables, the sheer volume of habitable real estate suggests that the spark of life has likely ignited elsewhere. Statistically, we should be part of a crowded galactic community. Yet, despite decades of scanning the skies, we have never detected a single confirmed alien signal. Physicist Enrico Fermi famously pointed out this contradiction with a simple question: where is everybody? This tension between a mathematically crowded universe and an empty sky is known as the Fermi Paradox. The silence suggests that for any civilization to reach Earth, they must first survive a brutal sequence of physical and temporal filters. This timeline tracks the 13.8 billion-year history of the cosmos. It highlights our first major hurdle, the mismatch of deep time. Human civilization has only broadcasted radio signals for a century. On this scale, our history is an invisible sliver at the extreme edge. Because this window is so brief, we could miss vast interstellar empires by millions of years, arriving far too early or far too late to ever make contact. Then there is the Great Filter. This theory proposes a developmental hurdle so difficult to clear that it prevents biological life from ever becoming an interstellar species. This filter might be the inevitability of technological self-destruction, the point where a civilization masters nuclear energy, climate-altering industry, or rogue AI, before it masters the social stability required to survive them. Surviving long enough to overlap with humanity's timeline requires overcoming near-impossible odds of self-annihilation. This diagram maps the distance from Earth to our closest star system, Alpha Centauri. It is over 4 light-years away. With our current chemical rockets, the journey would take tens of thousands of years, requiring a commitment that spans hundreds of human generations. To bypass this speed limit, an alien species must master theoretical concepts like warp drives, a technological leap that separates us from them by thousands of years of development. If a civilization did conquer these distances, we have to ask why they would choose Earth. Sci-fi often assumes they would come to harvest our water or mine our minerals, but the cosmos is flooded with accessible water and minerals on lifeless moons and asteroids. Mining a dead rock is far more efficient than contending with Earth's gravity and its locals. Their motives would likely mirror our own reasons for sending rovers to Mars. Curiosity and scientific study would be the primary drivers, treating Earth as a unique biological exhibit. If an arrival ever occurs, they wouldn't land as conquerors. They would be scientists studying a rare and fragile sociological anomaly. Recognizing the immense physical barriers of space has forced humanity to stop waiting for a visitor. We have entered an era of proactive hunting, using tools like the James Webb Space Telescope to scan the atmospheres of distant exoplanets. We are searching for biosignatures, like oxygen and methane, or technosignatures, like industrial pollutants, that would reveal an advanced civilization in the dark. Occasionally, the universe brings the evidence to us. In 2017, astronomers tracked Oumuamua, the first confirmed interstellar object to pass through our solar system. Its unusual shape and acceleration led some researchers to suggest it could be a piece of defunct alien technology, a solar sail drifting through the dark. The Fermi Paradox has shifted our focus. If the laws of physics currently stand as a barricade between our worlds, then our search for biosignatures is the first step toward bridging that gap. By building the tools to detect life across light years, we are ensuring that if they never come to us, we are finally preparing ourselves to